Hey, hi everyone, welcome back. I hope that you all managed to have a bite to eat, get some movement. I think the theme of this next talk is going to follow on really nicely from the discussions that we've just been having. Christie Aschwanden, journalist, author. I highly recommend everyone checking out her work, particularly Good to Go, her book. But yeah, don't know what I'm saying now, Christie. I'm just going to hand straight on over to you. My brain is getting fried at this stage. I can't remember what I ever said. Thanks a million for coming along today. Really looking forward to hearing your talk.
Oh, thanks so much for having me. I will share my screen here. Let me make sure I'm doing the right one. Can everyone see this?
Yep.
And now I just need to start the slideshow. Let's see, how do I do this? All right.
Yep, we're seeing and hearing you perfect.
Okay, great. Yeah, it always looks a little different from the speaker's view. Thanks so much for having me. I am so excited about STORK. I think a lot of you know that. I wrote a story, 538, when STORK was first forming, and it was really exciting to me to see this. This is a picture of the US and UK version of my book, Good to Go. I think some of you are familiar with it. Basically, it's a meta-science book, sort of gussied up as a book about exercise recovery. The first chapter is about a study I did on beer and running, and all about sort of the hijinks that can happen when you try to study something with science and how tricky it can be. In the course of researching the book, I interviewed over 250 experts, scientists, trainers, coaches, athletes. I read literally hundreds, I would guess maybe even close to 1,000 scientific papers. So I really went deep into the literature on this stuff. I'm a science journalist by vocation. I've done a lot of writing about medicine and other kinds of science. I had been sort of writing quite a bit about sports and exercise science over the years, but I don't think I'd ever really gone so deep on one particular subject. And so I learned a few things along the way. The first thing that I learned, and it was a little bit shocking to me actually, was the quality of the evidence, at least pertaining to exercise recovery, was quite a bit lower than I would have expected. I guess in retrospect, it makes sense. This is not, I want to be clear about this, and I think this is a topic that's come up already in this conference, but this isn't just a matter of people doing shoddy research or wanting to do shoddy research. There are some sort of inherent problems. It's very difficult to do large sample sizes in this field, and that's a problem. It's a problem that doesn't go away, but it's not necessarily something where people are just intentionally trying to use bad practices. But I think the really big takeaway that I learned here was that science is just really hard. It's a lot harder, I think, than most people understand, and particularly the general public and people who are reporting on science and talking about it or trying to apply it to their lives. But I think that even among some scientists, there's not always this recognition about the difficulty of science. And this is where we get to sort of the title of my talk, which is Intellectual Humility, which is defined as the degree to which people recognize that their beliefs might be wrong. And I just think, this is something that I've kind of learned along the way reporting on this field, is that we just have to be really careful about over-interpreting things and kind of take a step back before we jump too quickly on findings and decide that they represent, the final truth. So while I was reporting on my book, I was also doing a lot of research and reporting on what's been sort of termed the reproducibility crisis. At the time, there was a lot of discussion, is science broken? Is it sort of irrevocably broken? And after doing a bunch of research on this, talking to lots and lots of researchers in various fields, the thing that I concluded is that science isn't broken. It's just, as the subhead here says, a hell of a lot harder than we give it credit for. And I think this is going back to the humility part, just sort of recognizing that we're really doing something very difficult here, and that science is the most rigorous and best way to understand the world, but it's also kind of a slow process, and it's something we need to have patience. I think Nick really did a great job earlier today of explaining all the incentives are not usually aligning. for this. So there's a lot of incentives to go faster and to not bring this humility to the research. And I'm just going to argue that we need to slow down a little bit. So just really quickly, I wanted to tell you about, as part of that Science Isn't Broken article, we did this fun little p-hacking interactive. I wanted to explain p-hacking to the general public, which is almost impossible because no one knows what p-values are. So we gave them this toy that they could use to try and actually do it. And so here was a scenario. You think the US economy is affected by which political party is in office. And so we used real data sets going back to 1948 in order to give people a chance to sort of play around with this. So the idea here is that most people have a preference for the answer, what answer they want to get for this question. And so by playing around with different terms, so the first problem that you hit when you are a researcher doing a study is, okay, what's my study question, but then how am I going to answer it? And so here you had to choose, like, how are you going to define the terms? Are you talking about presidents, governors, senators? What do you mean by which political power or party is in power? So we gave people an opportunity to try out all of these different things. And what we found is that there were 1,800 possible combinations. Over 1,000 of them yielded p-values of less than 0.05, which, as you all know, is often considered publishable. Basically, you could p-hack your way to whatever conclusion that you wanted. And this is something where I think a lot of people take as the lesson here that, okay, if you just fish around, you can get the answer that you want. And I think that's true. But I think there's also another really important takeaway here that maybe doesn't get discussed as much. And that is the answer you get depends very highly on how you ask the question. And so you need to ask the question a lot of different ways if you're really doing this to try and get to scientific truth. And I wanted to just make a comment. I think it was in the last talk, someone made a comment about how not everyone is doing science in order to sort of get at scientific truths. And one thing that I came across again and again while I was researching this book on exercise recovery is that there's a large body of research, and I use the term research sort of loosely here, but there are a lot of studies that get presented and cited and pointed to that have not actually been done in the quest for scientific truth or really understanding how things work, but that they're really just marketing projects. And so you have a lot of science that's being done now that's really just trying to make a product or an approach or an idea scientific. And I almost think of it as science washing. And I don't think that this is the majority of research, and it's certainly not the most research coming out of universities, but there's a lot of marketing type science that's being really focused and bombarded to consumers. And there are a lot of consumers in the exercise and sports science space, including professional teams and professional athletes who really fall prey to this stuff a lot. So going back to my previous point about how you ask the question, I just want to tell you about a couple of projects. You may have, if you've heard me speak before, you've probably heard me speak about this. I really like this study. This was a big project, open crowdsourced project that was done, spearheaded by the Center for Open Science. And what they did is they had one data set, 29 teams that signed up, but they were trying to answer this seemingly pretty straightforward question, which is, do soccer referees give more red cards to dark-skinned players than to light-skinned ones? And this would seem to be a pretty straightforward question. You have 29 teams using the same data set. You would assume that they would get the same answer. Well, these are the answers that they got. The bottom line here is that they would be equally likely to give a red card. The top bar is 3 times as likely. Those gray bars are showing the 95% confidence intervals. So you can see that there's a lot of uncertainty in a lot of these answers. But if you were to look at just one of the results, you might think that you had a pretty solid answer. It's only when you look at them in their totality that you see that, okay, there's probably something there. The effect is not really, really large, but it would have been possible if you had only done one analysis that you might think that the effect was more extreme than it is, or you might have more or less confidence than you could with more interrogations of the question. Here's another sort of similar project. Eric Ullman at INSEAD led more recently. They had 5 psychology, this was a psychology project, looking at 5 different hypotheses. A few of these had already been tested, but they did not share the conclusions that those initial studies had shown. And what they did is they recruited, again, this was a crowdsourcing project. They ended up with 15 teams total, a minimum of 13 teams per hypothesis. And what they found, here's a pretty representative one. Here's a single hypothesis, all of the different answers in the different directions. So what you have on the x-axis here is effect size, positive, negative. I'm sorry, on the y-axis. The x-axis is just each individual team. And you see here that you're getting answers in every direction. And what they found is that 4 out of the 5 hypotheses, researchers found quote unquote statistically significant results in opposite directions. And I feel like there's probably been enough discussion, and all of you know all of the pitfalls of statistically significant and all of that. So I won't go into too much detail about that. But I think, you know, really the important point here is that it's a lot easier to get a result than it is to get an answer. And we have a lot of instances where we have results that are really heralded as answers, or the final answer, or something that's worth taking action on. And I guess going back to the idea of intellectual humility, I would just argue that sometimes we need to stop and slow down a little bit. And I say this as a journalist who's reporting on this stuff. And so all of my incentives are to hype it and to, you know, make it something that a reader is going to click on. So, you know, researchers have incentives to have high impact factors and all of that. Journalists, particularly if you're writing on the internet, it's all about clicks and things like that. So, yeah, sort of at every step here, the incentives are pushing in the wrong direction. Nevertheless, I think that we should do the right thing. And so I just wanted to talk here about one particular example of this. And that is the case of nutrient timing in the anabolic window. I'm assuming that most of you have heard of this. This is the concept, or this idea. There's actually a couple of different versions of it, but it's this idea that after exercise, particularly a hard aerobic exercise, or strength training where someone is trying to build muscle, that there's this like very short window, the anabolic window, it's called in regards to strength training, or the recovery window, where it's just really important to get some nutrition. So it's either carbohydrates to restore your glycogen stores, or protein, or a combination of the two. But with strength training and muscle building, it's really about getting protein in this short period of time. And the idea here is that your body is most able to take up those nutrients, and that it's crucial that it's done at this particular time. And if you don't hit the window, you're really missing out. The problem, though, is that this idea, it didn't come out of nowhere. It came out of a particular few early small studies, as very often in exercise science, these studies tend to be small. But basically, it was a preliminary finding that was sort of seized upon and taken from there. And the next thing you know, you have all of these products that are being marketed. And once something is monetized, particularly in this field with exercise and sport, it's really, really hard to change opinion on it and to change practice. So this study here is a meta-analysis of the effect of protein timing. And what it found was that it's not the timing that seems to be important, it's just the consumption of the protein itself. And so this study is particular to strength exercise, but the similar findings have been done for the glycogen stuff as well. Anyway, so the idea here is that, you know, what seemed like timing was probably just a relic of the way those initial studies were being done. And so, you know, instead of saying, well, this is an interesting finding, we need to try and replicate it, we need to keep going. You know, those studies were eventually done, but it was really, everyone jumped on it. And once you had these companies, some of the people that did the initial studies were actually marketing some products. And once that happens, it's really hard to stop the train. This is another follow-up, which was looking at pre versus post-exercise protein intake. And what this showed is that it didn't, you could actually take the protein before the weight workout and still have similar effects. So this idea that there was this narrow window was overturned, that now we have a situation where we still have all these products, we have this advice. I mean, as a journalist, I get almost on a daily basis these pitches from PR people marketing products that are relying on this recovery window concept. I've sort of developed a rule of thumb about this stuff, which is that the more tidy and extreme the result, the less likely it is to reflect the real world. Real life is messy. We're all always looking for the magic bullet, the one thing that's going to have a big effect. But in the real world, there aren't a lot of those things. When we find them, it's really exciting, and science is a great way to find them. But oftentimes the effects are smaller and they're very dependent on conditions, and that's okay. That's why we need multiple studies to look at this. The corollary to this rule of thumb is that the most accurate answer is usually it depends. Now, of course, no one wants this same it depends answer for all time and every single thing. So it can get to be a little bit frustrating, I think, for people, particularly for my editors who are telling me, what do you mean, once again, you're having all of these caveats? But I think it's really important that we bring this humility to things. And this often gets blamed on the media, like we're the ones who are hyping findings and making things seem more important or more significant, or effect sizes to be larger than they are. Things like that. I'm thinking, I think it was just last week, I saw in the New York Times yet another study looking at coffee and health benefits and so the takeaway of this study was that coffee was really good for you. But the journalist actually quoted one of the researchers saying, I'm paraphrasing here, but something to the effect of, this is really huge. There are very few things that increased lifespan by 3 times or something like that, but it was a 3-fold increase in the beneficial result. And in fact, the study had not found this. This was a correlational study. If you're interested in the shortcomings of nutrition research, I wrote a piece for 538 called something like, "You Can't Trust What You Read About Nutrition," or something like that, looking at all of the problems with this self-reported and observational data in nutrition studies. But basically, this wasn't just the newspaper here hyping stuff, it was the researcher themselves. And I really do think, and this is my experience, that very often the lack of humility does not begin with journalists. Journalists may not always tamp it down to the extent that they should. And I really do believe that as a journalist, part of my job is to be skeptical, a sort of trust but verify approach to things, in the same way that I would be doing if I was covering some other topic like politics. A lot of people sort of misunderstand and think that science journalists should be promoting science. I don't think, and our profession is not really built to do that. Our profession is to report on science and report on findings, particularly publicly funded science, and to really hold truth to power in this. So it is journalists' job to be skeptical and to be watchdogs for science, but it's not, it's hard for us to stop it at the source. And so often the hype really comes from the press releases, it comes from the abstracts, it comes from the scientists themselves sometimes. This is a story that I wrote in April 2020 for Wired, and this was about COVID, but I think that there are some lessons here for sports science. Here I was really arguing, this was April 2020, so we were early on in the pandemic, and there was really this feeling at that time like, oh my gosh, we're in this panicky situation. This is a global crisis. We need to get whatever data we can as quickly as we can. And my piece was really arguing that, yes, we need good answers, but that the urgency of COVID was not a reason to drop all of the rigor that we need to use to approach science. And in fact, I think the core of the argument here in this piece, this was an ideas piece, so it was a little bit more op-edy than a just straight reported piece. But my argument here was that bad data is actually worse than no data at all. And so if you're working really fast and using shoddy methods, you can start to create beliefs that can become fixed, or even practices that may in fact be harmful. We saw some of that in COVID. We've also seen it in sports science. And I don't know, I was unable to attend Kristen's talk yesterday. I was teaching at that time. I'm assuming she may have talked about this. Maybe she didn't, because I'm hoping that this has just gone away. But this is a piece that I want to just really emphasize how much Kristen Sanini was part of this. While researching my book, I kept finding again and again this research method called magnitude-based inference. And I'm no statistician, even though I worked at a statistician, website. But I thought, this just doesn't seem right to me. I don't think it can really be doing what it purports to do. And what it purported to do was basically make it easier to find significant findings. And I thought, well, that seems like it's breaking the laws of physics. And so I took this method and I brought it to multiple statisticians who mostly just laughed me off and said it wasn't worth my time to debunk this thing. Finally, thank God I found Kristen, and she really took it on and has just run with it. And I think a lot of what's happened since then is really because of her. So anyway, so what MBI does, which it was just basically, I think if you're using a statistical method that is only a series of Excel spreadsheets that you have to download, from some other guy's computer, it's probably not a rigorous system. Like, you probably do want to see some justification and published and other statisticians that think it's worth using. But basically what you can see here, this is from a graphic of my story, that basically what MBI is doing is it's making it a lot easier to find an interesting effect, but the chances that that effect holds up and is real is much, much less. And so, of course, it was exciting, and you can understand why this was popularized. But it was popularized because it was basically loosening the standards, which I would argue, and I think probably most of the people in the room here would agree, is the opposite of what we should be doing. And this gets me to another, what I think is a really important point, and that is, one of the things that I found out as I was reporting this story, it was so puzzling when I would talk to people outside of the exercise and sports science field, how this could possibly have gotten traction and how was this being published in these sport and exercise science journals. And I think, that the answer that I ended up finding was that this was really a cultural thing. This was, it's not just in exercise science where a lot of people are intimidated by statistics or don't have a really deep grasp of them. This was a very appealing method. And, it was being promoted by someone who was eminent and had a large following. And so what was happening here was really sort of a cultural phenomenon rather than a scientific one. And I think it's important to understand that what STORK is doing, and sort of this movement to increase the rigor in this field, is really, you're talking about a culture change. And that's hard. Culture changes are hard, but I think it's worth thinking about it a little bit from a psychological and a sociological perspective. Because, part of what's happening here, part of the reason MBI really took hold is that you had some people who were advanced in the field who were promoting it and using it. And so they were teaching their students to use it, et cetera. And that's how it propagates. And so, you really have to think hard about, the culture of science and how that affects how science is done. So the other thing about MBI is that it wasn't just, it's not just a problem that like one study is bad, but it can kind of pollute the scientific literature here. And now, now that we see this, I was going back, this is a meta-analysis of a meta-analysis of the effects of foam rolling. And if you look at this, just raw, it looks like, well, there might be an effect here, but all of the studies here that are highlighted in yellow used MBI, and that's how they got these sort of outlier findings. So if you were to drop those findings, all of a sudden the effect doesn't look quite as interesting. So it's really, the problem isn't just one study being bad. It's that, I used to think that meta-analyses were really a great way to figure out what's going on, but I've really kind of tempered my feelings about them over time. And so much of this was going on this deep dive for the book and realizing that a lot of times, it's like garbage in, garbage out. And if a meta-analysis is looking at garbage findings, their answer is going to be garbage too. And there are a lot of ways to do these improperly that can really set you on the wrong course and be deceptive. This is a paper that I hope some of you or all of you should be at the end of this familiar with. And this is Renk Hoekstra and Simine Vizier. I'm sure most of you know at least Simine. She's been a leader in SIPS. This is a great paper that was published in Nature Human Behavior about bringing intellectual humility to science. And this paper has some really great suggestions, many of which have already come up here, about how to bring this humility to science. And a lot of this is about being more cautious and being more careful about how we interpret things, being more careful to recognize that any single piece of work could be wrong. And I think that so much of this really comes down to something that I've been doing a lot of thinking about, and that is uncertainty and the role of uncertainty in science. And I think that the more that uncertainty is sort of downplayed, the further we get the further we get from really good answers. And what I've realized and come to see is that so often the really interesting findings come from interrogating those pieces of uncertainty. So like looking at the edge cases and looking at, okay, we made this finding here, but does it hold up in other circumstances? And it's only by testing it in those other circumstances that you really start to understand how that particular phenomenon works. But so often, I think in this field, the instinct or sort of the standard practice has been to take that initial finding and just keep going. And instead of really trying to figure out under which circumstances, this goes back to the whole idea of it depends, it depends on what you want to know. And, instead of going back and looking at all of those cases and trying to figure out the instances where it holds up and the instances where it doesn't, instead, what happens is, and sometimes this isn't even on the researchers themselves, but there's a finding. And so a company comes in and they start making a product based on that. And so all of a sudden now they're doing research that's going to back that up, because of course it is, because we all know that if your goal is to do a study that shows a particular thing, there are ways to do that using QRPs. In order to basically science wash your product. And I think that that's a really, really big problem in this field. In my book, I talk about it, sort of document this instance in nutrition science where you had these researchers who were promoting supplements and they were getting laughed out of the ACSM. And so they went and formed their own group, their own scientific organization, their own journal. And so if you don't know better, this looks very scientific, and they're doing studies and they're designing them and publishing them, but it's all with this purpose of promoting these products. And you look at the people who are promoting the stuff and running these organizations, they all have very close ties and they're being paid by these manufacturers. And this is a problem. And I think it's something that, this goes along with the whole issue of predatory journals and things like this. I mean, in this day and age, it's possible to publish stuff and have published research that to untrained eyes looks really legitimate. And I think this is a further challenge to helping people understand what's going on. This is my contact information I wanted to share with everyone here. One thing I wanted to mention to you, my publisher does have a program if anyone is interested in using my book, if you're teaching, and I really enjoy speaking to students, so I'm happy to do that. But I wanted to leave some, I think we have about 15 minutes, is that right? I wanted to leave some time for questions. I see it looks like there's a lot in the chat, which I haven't been able to see. Let me see how I stop sharing. There we go. Emma, did you want to read any or highlight any particular questions, or I can look at this, but it's.
Yeah, I have a terrible ability to do two things at the one time. So I've been sending some messages in the chat and keeping up with some of it, but not always. I think we do have good time to discussion now. If anyone who wants to, just unmute yourselves and ask your question now, and I'll scroll through and pick out some of the questions from the chat.
Sure.
But feel absolutely free to unmute yourself and ask questions or comments directly. I think just while I'm scrolling through the chat, Christie, one of the things that I jotted down at the beginning is like, where does this lack of intellectual humility come from? Because it just seems, I get that like propagates and I get that things, but
yeah. I mean, I think it's really interesting because the scientific ideal, right, is that the scientific mindset is that you're always open to new information, to new data, that, you know, science is never the last word, and that you have to be open to new evidence. But I think, yeah, a lot of this comes down to science is done by human beings, and we all have our biases and we have things. And yeah, I don't think you can downplay the role of the incentives too. And again, you know, I think most of the discussion here has been about incentives in science and among scientists, but as a journalist, I have incentives too. And it's much easier to sell my editors on a story that's saying, you know, oh, scientists found this magic bullet for exercise now, than it is to say, well, there was a study and it was kind of interesting, but caveat, 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 like no one really wants to read that. And at the end of the day, the public, you know, when they are acting on the research, they just want to know, should I do it? Should I take it? You know, should I buy this thing or should I not? And I think maybe one of the things here is just slowing down and saying that, you know, maybe it's not ready to be acted on yet. There's almost been this sense where research has been monetized and popularized before it's ready. And that's one place I often think that as a journalist, one of the most important things that I do is decide not to write about things. There are very often times when I see a paper that I know will make some sort of, for instance, that coffee paper that I was talking about, that was just in the news, I think it was last week, you know, I would probably choose not to write about that. If I did write about it, I would probably, I've actually written, if you look it up, I wrote a piece for Slate some years ago about coffee in particular. You know, it's so often brought up as this example of why we can't trust science or why this stuff is sort of unreliable, because one day it's good for you, one day it's not. And so I sort of wrote about that. But I think that, you know, we really need to be careful about translating science into people's lives and maybe be a little bit slower about it in some instances. And, you know, again, this is where incentives aren't aligned for that. That as a journalist, it's something that I've done a lot, and it's probably hasn't helped my career. But yeah, I would have sold a lot more books had I said, here are the 10 things that will just rock your world, and they're all things that you can buy, or that, you know, little hacks. The number one criticism of my book, in fact, if you go on Amazon, the top, I haven't looked at it in quite a while, but the last time I looked, the number one comment on the book was something like, this book sucks. It just says that nothing works, and just sleep more and you know, take rest days. And I'm like, yes, you read the book. This is great. Anyway, it looks like John has a question.
So just to follow on that, though, when you said maybe I'd do better, I think that should be judged at the very end of a career, because I think people can do very well in the short term selling quick fixes, but whether they're around in the long term and whether their work withstands the test of time, story. We have a couple of questions, first John, then James, and everyone feel free to.
Yeah, absolutely.
Thank you, everyone. Thank you, Christie, for the talk. I think just following on from that point, I think one of the criticisms lots of academics have towards journalists is this kind of lack of statistical literacy. So obviously you're somebody that's bucking this trend. I wondered what your thoughts were about your, we are recording this, but maybe you can tone down the criticism about your colleagues
it's okay.
and how we kind of approach some of these issues, because like you say, there are lots of these stories and there doesn't seem to be incentives from your end to actually, it's kind of willful ignorance on some people's part, because actually if you know, then you know, and you can't peddle the stories that are going to advance your career, perhaps.
Yeah, it's kind of hard not to unsee it. And I haven't done this because I think I'd be too horrified. But I know, you know, if I went back and looked at stories I had done early in my career, I'd probably be cringing, because I wrote some of those stories about, you know, blueberries prevent cancer and, you know, all of this crappy stuff that just gets published all the time. But I do think there's a couple of answers to this. One is that there is a group, and it's not tiny, of science journalists who are aware of this stuff and who are trained on, you know, I went to this program at UC Santa Cruz that sort of specializes in taking scientists and turning them into journalists. So I was the only person in my class without a PhD. I have an undergraduate in biology. but we all sort of had a scientific backing. There are a couple of other programs like this, but there are trainings taking people with science backgrounds to become journalists. So my point here is that there are quite a few working journalists that have good training in this and are not the ones who don't know better than that. But you're sort of swimming against the tide in a lot of places, and it really, I think the worst offenders are actually not places like the Washington Post and New York Times. Those are places that I write for, although like I just called out a New York Times piece, right, that I thought was pretty terrible. So it's not universal, but there are a lot of people who are trained and know more. There's also, I speak a lot to journalists at conferences and things about these issues. I'm currently vice president of the board of the Council for the Advancement of Science Writing, and we are putting together a series of workshops. Kristen Sanini and Regina Nuzzo are going to be leading them for journalists, teaching them statistics and showing them stuff. So there are trainings available. I mean, it is something that as journalists, as a field, we are trying to address, but not every, a lot of the offenders are not people who self-identify as science journalists and aren't people who maybe are going to be seeking that out, getting that training. So James.
Hey, Christie. Thanks for the talk again. Good to catch up. I was interested because I don't think a lot of people here will be aware, but you don't just write about topics that broadly fall under the kind of banner of kinesiology, sport, exercise, health sciences and such. So in your kind of coverage of other areas of science, are there any kind of key, I'm going to say kind of, to use your term, psychological and sociological kind of trends or things that you've identified that other fields do better in terms of bringing humility to the work that they do that we could learn from?
Yeah, that's a really great question. And it's interesting because, as I started, I was kind of talking about, I started reporting my book right about the time I was really doing a lot of research on the replication crisis, but talking a lot to psychologists. And I feel like in a lot of ways, I think STORK is kind of modeled a little bit on SIPS, right? I think SIPS is a great, there's been a lot of great work in psychology looking at this, but medicine as well. There are now, if you're doing clinical trials, they have to be pre-registered. There's been a shift there, and there's some really interesting research there, which will surprise no one here. But when you do clinical trials that are all pre-registered, all of a sudden you get fewer positive findings, which is exactly what you might expect, right? And that's, feels to me like they're maybe solving a problem. But what was really interesting to me is that, so as I was reporting on sort of the stuff going on in psychology, I do a lot of reporting on medicine and health as well, and clinical trials and screenings and things like that, and realizing that so many of the practices that are just completely perfectly normal and acceptable in sport and exercise science would just be like horrific. Like no one would allow you to do that if you were doing, say, clinical trials, and so just a really easy, for instance, is like, you couldn't publish a clinical trial in medicine with an N of 12. Like that just isn't, that would be called like a preliminary, like maybe not, it's not going to get in JAMA. And yet, that is just something that's still sort of standard practice in exercise science. And, I understand there are reasons for that. And so I want to be sort of generous about intentions there, but you can't get away from the fact that, small studies are intrinsically problematic. And so the way to solve that isn't with, invented statistical methods, it's with figuring out ways to get larger samples. But I do think, I think that psychology provides a really great model for sort of the culture change that's happening and what you see. And I think what you're up against and, what the previous talk here was really addressing is that you have a system where the people who are sort of at the highest rungs have gotten there through the existing practices and through the existing culture. And so it's not surprising that a lot of the movement for change is coming from the bottom, from graduate students and from postdocs, because they're seeing another way. And all of the people who are, the senior scientists right now, they came up through a system that they are used to and that has benefited them, and no one likes change. And particularly, if you've succeeded doing certain things, you don't want to have to change that. And so that's a really difficult problem. And I think, there is that issue that there was a lot of talk and a lot of conflict in psychology about, the stuff we were just talking about with, criticizing, particularly over social media and things like that, and whether that's okay. And I think part of this culture change that needs to happen and is happening is around sort of what are the norms that we're going to have and we're going to accept about how is criticism delivered, when is it appropriate, who can give it, things like that. And I think this is just like, these are hard problems, and there are sort of growing pains among them. And I think, I'm really glad that STORK is sort of collaborating or getting so many lessons from SIPS, because they've sort of gone through a lot of this. And I don't know that they've cracked everything, but they've at least, you're probably not encountering novel problems at this point. Oh, did someone else have a question? Yeah.
Amy is not unmuted like usual.
Oh, yeah. You're muted.
Apologies. It was also a rambly preamble with no actual really saying anything. Basically, I was just saying I stuck my hand up because I have a question, but I'm also aware that everyone is probably sick of hearing me, so anyone else can jump in front. And Christie, I was just wondering, on the point of view of a science journalist and a science communicator, what advice would you give to scientists? Not me personally, because nobody wants to talk about my research. It's not very interesting. But having spoken to so many scientists, what's the attributes of a really great source for a journalist like you? How can we help to bridge this divide between doing the work and communicating the work?
Yeah, that's a great question. I think a couple of things are really important. One is being able to translate your work into English and to sort of like, why does this matter? And I'm never going to use a word like confidence intervals in my story, but I need to know what they are and what that means. And sort of, I'm always sort of suspicious when I'm working with a scientist who's saying, yep, this is it. This is how, I want to know where are the uncertainties, where are the cautions, things like that. At the same time, though, I think it is, it's easy for people to say, well, everything's really uncertain, so we don't know anything. And I don't think that that's correct. I think, we can still know things even in the face of uncertainty. We just have to be sort of, this is where the humility comes in about, having some humility about this is the best idea that we have right now. Here is our best understanding. And so we're going to promote that and share that, but with the caveat that this could change. And here are the 3 areas where we really do still have some uncertainty. So we want to be a little bit more cautious, if that makes sense. Another thing is really, I'm sure no one here would do this, but when I ask someone for an interview and I tell them I want to ask about your study, and they say, oh, here's the study, you can just read it. And it's like, well, I probably by the time I'm contacting you, I already have read it, but also I can't quote your paper, and I can't, I need you. And very often, it happens to me quite often, actually, where I'm about halfway through an interview and the person says, wow, you really know this, because they don't realize a lot of the questions I will be asking are on the behalf of my readers. And I'm really, I'm wanting to get answers that are not written to, the level of someone who maybe understands all the statistics, but it needs to be translated. And so, I like to say, if you imagine that you're at a bar with some guy or gal who, doesn't know anything about this field, how would you explain it to them and how would you convey it? And I think the more that you're able to do that, but again, here's the danger is that, okay, so then you're just going to, oversell things. So it's a little bit of a dance. It really is. Yeah. I think going back to the idea of humility, I really think, I'm a little bit on a crusade, I guess, now to help not just scientists. I mean, I think that the default for scientists, at least the ideal for scientists, is to have this intellectual humility, which is absolutely not to say that it universally exists and that there's no work to be done there. But I think that one area that I'm hoping that I can make a little bit more of a difference is just helping the public develop a little bit of this and to understand, I think where I've sort of landed finally after many years of writing about this stuff is that one of the fundamental challenges that I face as a journalist is that, too often the public really just thinks of science as almost magic. Like you do a study and now you know everything, but that's not how it works. But the extent to which they believe that that's the case and that science is this magic wand, it really makes people very vulnerable to misinformation, to disinformation, and to, bullshit, frankly. And so I think the more that journalists, scientists too, can help the public understand that science is really hard, that we don't always get good answers right away, and that the answers that we get are provisional and we need to be open to new evidence. I think that it could make for, a better public understanding of science and consumption of science, and, will help people maybe develop a little bit more skepticism about some of the outrageous claims that are made. And, you have all probably seen it, but the claims that are made regarding exercise stuff and products are just, they're almost comical, some of them. And yet there's such an appetite, people want easy answers. And so, it can be, oftentimes I feel like I'm sort of swimming up against the current, frankly. And I would welcome other people's thoughts on how to do that. I do think that a lot of you teach universities, and that seems like a good place to start with some of this.
Zach, go first.
Just thank you for the wonderful talk. Just very quickly on that, in the teaching setting, I find that some of my students have a very strong need for closure and need for concrete answers. And there's a very understandable frustration there when I say, I don't know, we don't know. The science hasn't been done yet. You can go do that research in the future.
Yeah.
So, but they're willing to learn, and they're open to those types of responses. But initially it can be pretty difficult.
It's really tricky. And I think some of this is just, as humans, the human brain does not like uncertainty. And this is why, we've seen this so much in COVID. You have these purveyors of bullshit who are offering absolute certainty, when, the scientists who are really working on this stuff, we know a lot more now than we did in March of 2020, but it's taken a while, and it's really hard for the public to sit with that, especially, when people are dying, and it's scary. And so it's very understandable. And I don't know, there aren't easy answers. If there were, we would have solved this already. So I'd love to hear from Aaron. Oh, sorry, Zach, did you have something else? I didn't mean to cut you off.
If we're going in order, James put up his hand first, and then Aaron first. Sure. Whoever wants to.
Yeah.
No, I don't want to monopolize. Aaron can go.
Aaron,
okay,
I'm done. Thank you.
Okay. Yeah, sorry. I wasn't able to see the whole talk. I've been unfortunately unable to attend most of this due to work, but the part I did talk, really impressed. Great to have you here, Christie. My question to you is, you mentioned that skepticism, and I've heard it expressed through others, and I'm increasingly wondering about this. Do you think that increased skepticism could also come with, well, I guess it would have to, like a lack of trust in science, so we sacrifice a little bit there. And so how do we kind of navigate that dangerous space between being more skeptical of those outrageous claims without becoming so distrustful or cynical of the science, right? And my mind immediately goes to some of the reactions to the pandemic. So I don't know if you have any comment on that, because, you interact with more of the public than I think we do, considering we're kind of in our own echo chamber sometimes.
Yeah, I actually wrote a piece about this. I don't have a link handy, but you could find it very easily. It's called "There's No Such Thing as Sound Science." And this story was about how basically this effort for open science and to make science more rigorous has been weaponized by nefarious forces who are trying to undermine science. And this has happened, this predates I think some of the current movements to make science better, although those movements have been around for a long time in different forms. There's sort of nothing new under the sun here. But it's a really difficult problem. And I think some of it is helping people just better understand. I do think that a better understanding of the scientific process can help shield that a little bit. It's always going to be hard. As a journalist, sometimes I find it hard. Like, how do I know who to trust? What do you look at? People, these nefarious forces have gotten very good at using some of the same arguments and things, calling for open data and things like this. And well, we can't trust these findings because they're not open with them. Sometimes there are good reasons for that. This is something that's happened a lot sort of with regulatory decisions. So for instance, data that the EPA or the FDA might have where there's patient privacy and things like that. So there may be legitimate reasons for that data to not be open, but they're being undermined and things like that. So that's kind of a long-winded way of saying that I don't really know. I don't have a good answer. I would love to hear from anyone who has a better answer, but I think it's really tricky. But I do think, because some of these tactics are about whipping up uncertainty. So not just whipping it up, but taking the legitimate uncertainty that's there and sort of making it bigger and saying, oh, this is uncertain, therefore scientists don't know, and it's not scientific, when in fact we know that uncertainty is a feature of science. It's something that does not go away. Science does not eliminate uncertainty. And so using uncertainty as a reason to dismiss science that's not right. And the only way you understand that is if you know that uncertainty is part of the science. If that makes sense. James.
Yeah, I think actually both Zach's and Aaron's questions kind of lead on to what I wanted to say. I think one point on the discussion that was just had was a differentiation between skepticism and trust in the particulars of science versus the actual method itself.
Yeah.
And I think this is something we were discussing a couple of weeks back, that I've got this feeling, and I don't know how empirically true it is, but it kind of feels like it's kind of a reasonable description of kind of things, more broadly speaking, sociologically, in terms of science education at younger ages. Is I always remember science as being taught as physics, chemistry, biology. And there's a little sprinkling of kind of the scientific method somewhere in there, but it's lost between the kind of particulars of specific fields that are portrayed as being science. And, one of my kind of like bugbears at the moment is that I think, there's a tendency, even within the kind of more broadly speaking open science movement, to overlook the importance of education, better education around formal logic, philosophy of science, and just thinking scientifically, as opposed to kind of like specific debates about p-values and MBI and the like. Your thoughts on early science education?
Yeah, I mean, I think it can start early, and I think there's a lot that can be done of just like, helping people. I think if people are given a chance to try science and kind of do it, it becomes very, very clear, and I remember being in chemistry class in high school and having experiments not work, but we were never told, hey, this is part of, sometimes that happens. And it was just like, oh, you did this wrong, so do it this way. And I wish that had been baked into some of those lessons. But also, just teaching kids skepticism. And I think we have to be careful here, because the term skepticism and just the idea of skepticism has also been sort of weaponized too. So that's a little bit tricky and something that needs to be taken care, be used with care. But I think, so it's not just rejecting authority, but it's really, asking for receipts. I mean, I keep going back to this concept of trust but verify, and really wanting to see and understand, and teaching people that's how you understand. And it's okay to not take things at face value, but you can't just reject it. And now we have the situation though where everyone wants to do their own research, and we know now that everyone can go on the internet and find whatever answers they want. So it's tricky. It's really tricky. We're at a difficult moment with this stuff. Yeah, Nick.
Yeah, thanks, Christie, for the fascinating talk. I just wanted to firstly agree with what you say in terms of distinguishing between skepticism and cynicism. Yeah. Skepticism is a positive. It's good to demand evidence for specific claims, but not being cynical in that we immediately reject these claims. Have an open mind, but not so open that your brains fall out. Richard Feynman. Right. The other thing is that I wanted to say was I think there's a risk of conflating science education with critical thinking education, because somebody can be a very good scientist but a crappy critical thinker, And, you know, this has been studied quite extensively, and that the literature shows that actually there is a very, very weak, if any, correlation between science education and sort of skeptical or critical thinking related beliefs. So you can be a good scientist and have good knowledge of science facts and science theory, and still have pseudoscientific beliefs and but still believe in the paranormal and these kind of things. And so having a good science education does not automatically inoculate you against superstitious or false beliefs. And so actually, I think we need to be pushing to have critical thinking education separately integrated into science education, and even like you know, classes in research methods teach people how to be good producers of science, but doesn't teach people how to be good consumers of science. And there's a distinction there, you know, distinguish between science and pseudoscience, misinformation and information. And so I think integrating critical thinking in addition to science education, I think, is super important.
Yeah. It's interesting too. I don't feel like, and maybe I'm missing out, but it doesn't seem to me that there's enough education done and among science students in college about scientific methodology and things like that. I mean, I graduated from a pretty good school with a degree in biology and never learned about research methods or anything about, you know, just these basic concepts too. It doesn't have to be like how to design and, you know, set up the statistics on a study, but just these sort of basic ideas like I was presenting today, that, you know, the answer that you're going to get is going to be very dependent on how you ask the question. And so you need to be careful about how you ask the question, and just these sort of bigger concepts that I think, you know, are almost like meta concepts. I would love to see more of that taught, and that's stuff that could be taught at an even younger level in, say, high school.
Yeah, and research this is the thing, that research methods doesn't teach about you know, cognitive biases. It doesn't teach about media literacy. It doesn't teach people how to navigate social media. It doesn't teach people how to understand how the algorithms of social media create an echo chamber of confirmation bias. All of these things need to be integrated separately into science education, or independently, you know?
Yeah, absolutely. Absolutely.
Guys, I think this is the kind of conversation that we could do all day, and it's so interesting, but we're going to, let's try to keep to the schedule. However, I'd just like to say that the kind of things that we're discussing now, the concepts, are really what we're hoping we'll be able to carry up on in the final discussion. So I hope that everyone is around for that. Christie, I really hope you'll be able to, obviously depending on your schedule, but I really hope you'll be around to continue this conversation. Let's go on to John's talk now, where he's going to bring us back to the beginning in an effort for us to look to the future, and is going to talk about his experience of kind of starting a movement. And then, as I say, we do have a space scheduled at the end for a more open discussion, where I really hope we can carry on with some of these conversations. Christie, thank you so much. That was really...
Oh, thank you. I appreciate it. Those were great questions.
I'm going to stop recording this now and then start again. It just makes it easier for the files.